So, what if you could build a quality assurance engine that literally never sleeps and actually gets smarter with every single line of code it checks? Today, we're going to break down how a fully autonomous QA engine isn't just some far off concept anymore. It's a reality, and it's changing software development as we speak.
I mean, just let that sink in for a second. An engine that hunts bugs while you sleep. This isn't just about making testing a little bit faster, you know? We're talking about a fundamental shift in how we even think about code quality. It's a complete revolution.
A bug hunting AI sounds incredible, right? Almost like something out of science fiction. But what's the actual real world problem it's solving? Why is this something we desperately need right now?
Well, the answer is something every single development team feels deep in their bones: the manual testing bottleneck. It's this growing friction, this huge conflict right at the heart of how we build software today. And here's that clash in plain sight. On one side, you've got traditional QA, which is kind of like a turtle. It's slow, it's methodical, it's manual, and boy, is it expensive. Then on the other side, you have modern deployment, which is a total rocket ship. It's rapid, continuous, and incredibly complex. You just can't put a turtle on a rocket and expect it to work. And that mismatch, that's what creates the bottleneck. That's what leads to higher costs, mounting technical debt, and those painful delayed releases.
So, how in the world do you break a bottleneck like that? You need a completely new approach. And that brings us to the hero of our story today, the autonomous agent.
So what exactly is an autonomous QA engine? Well, to put it simply, it's an AI that handles the entire software validation process, from start to finish. And the key phrase here, the most important part, is without human intervention. It just runs on its own. You know, probably the best way to picture it is like this. Imagine you have a superhuman QA specialist on your team. It works 24/7, it never, ever gets tired, and it can analyze code and user interfaces at a scale that no human could ever hope to match. Okay, so the concept is obviously powerful, but how do you actually build one of these engines? Let's pop the hood and take a look at the core engineering that makes it all tick.
Architecting an engine like this really boils down to three key steps. First, you've got to build a flexible, modular core. Second, you teach it these specialized custom skills to hunt for really complex bugs. And third, you give it the ability to both read the code and see the application, which is a fancy way of saying multimodal reasoning.
Let's zoom in on those custom skills for a second. This isn't about your simple, everyday, click this and verify that kind of test. No way. This is about teaching the agent to think like a hacker, trying to break your system, or to spot those incredibly rare race conditions. You know, those super fleeting bugs that only pop up when two things happen at the exact same microsecond. And now for multimodal reasoning. This right here is the agent's superpower. It means it can both read the source code and visually see the application, just like a human would. It can spot when a button is off by just a few pixels, check that against the original design files, and know precisely which line of code caused that visual mistake. Now, I know what a lot of you are probably thinking right now. This all sounds great, but what happens when a developer moves a button or changes a color? Don't all the tests just break?
And this is the absolutely incredible answer: the tests heal themselves. The agent is smart enough to see that a button has moved, and it basically says, okay, I see the change. And then it automatically updates its own tests to match the new UI. That means no more spending hours and hours fixing broken tests every single time a small design change happens.
So this technology is clearly powerful, but is it practical? I mean, for it to really take off, it can't just be smart. It has to be fast, and it has to be cost-effective. Let's just be honest about the biggest hurdles for any advanced AI agent: speed and cost. High latency means slow feedback for developers, which nobody wants, and high operational costs can make it totally impractical. If it's not fast and affordable, it's just a cool science project, not a tool you can actually use. The solution is just a ruthless optimization. The engine uses a few really key techniques. Context window management is kind of like giving the AI a better short-term memory so it doesn't get lost. Intelligent prompt chaining is about asking the AI a series of smart, small questions instead of one giant, confusing one. And state-space pruning, that's the cleverest part. It tells the agent to just ignore parts of the app that haven't changed, which dramatically cuts down on processing time and cost. And here is the payoff for all that work. An unoptimized agent might take over an hour to give you feedback, which is way too long for a developer who's waiting to merge their code. But with these optimizations, the feedback time just plummets.
It becomes fast enough to integrate directly into a modern CI/CD pipeline, giving developers answers in minutes, not hours.
So we've made it smart and we've made it fast. But what's the ultimate impact? Let's talk about how this completely redefines what production-ready code even means. Because at the end of the day, this technology is about so much more than just finding bugs. The real game changer is creating a fully autonomous feedback loop that lives right there at the heart of your development process.
Let's just walk through this new workflow. A developer commits their code. The agent immediately tests it and finds a bug. But, and here's the magic, instead of just flagging it, the agent actually suggests a fix. And pretty soon, it'll even be able to apply that patch itself and rerun the tests, creating a truly hands-off, end-to-end autonomous loop.
What this all leads to is an entirely new standard. Production ready no longer means it simply passed a few tests. It means the code has been rigorously validated, stress tested, and maybe even improved by a specialized AI before a human ever had to look at it. And that leaves us with one final provocative question to think about. As we're barreling towards 2026, if your quality assurance process isn't autonomous, can you even really call it QA anymore? It's definitely something to consider.